Electrophoresis, colloidal particles properties we are discussing. The existence of charge on colloidal particles is confirmed by the electrophoresis experiment. When electric potential is applied across two platinum electrodes dipping in a colloidal solution, the colloidal particles move towards one or other electrode. The movement of colloidal particles under an applied electric potential is called electrophoresis. Positively charged particles move towards the cathode and negatively charged particles move towards the anode. This can be demonstrated by the following experiment. When electrophoresis, that is movement of particles, is prevented by some suitable means, it is observed that the dispersion medium begins to move in an electric field. This phenomena is called electroosmosis. Okay, this is the experiment that we are doing. Coagulation or precipitation. The stability of the lyophobic salts is due to the presence of charge on colloidal particles. If somehow the charge is removed, the particles will come nearer to each other to form aggregates or coagulate and settle down under the force of gravity. The process of settling of colloidal particles is called coagulation or precipitation of the salt. That means colloid gone. The coagulation of the lyophobic salts can be carried out in the following ways. One, by electrophoresis. The colloidal particles move towards oppositely charged electrodes, get discharged and precipitated. This is one chance. Otherwise, by mixing two oppositely charged salts when they mixed in almost equal proportions neutralize their charges and get partially or completely precipitated. Mixing of hydrated ferric oxide positive salt and arsenous sulfide negative salt bring them into the precipitated forms. This type of coagulation is called mutual coagulation. Both will be coagulated. By boiling, when a salt is boiled, the adsorbed layer is disturbed due to the increased collisions with the molecules of dispersion medium. This reduces the charge on the particles and ultimately leads to settling down in the form of precipitate. By persistent dialysis and prolonged dialysis, traces of the electrolyte present in the salt are removed completely and the colloids become unstable and ultimately coagulate. By addition of electrolytes, this is most important. When excess of an electrolyte is added, the colloidal particles are precipitated. The reason is that colloid interact with ions carrying charge opposite to that present on themselves. This causes neutralization leading to the coagulation. The ion responsible for neutralization of charge on the particles is called the coagulating ion. A negative ion causes the precipitation of positively charged salt and vice versa. It has been observed that generally the greater the valence of the fluctuating ion added, the greater is its power to cause precipitation. This is known as Hardy-Schule rule. In the coagulation of a negative salt, the fluctuating power in the order of Al plus 3, Ba plus 2, Na plus, Al plus 3 great. Similarly, in the coagulation of a positive salt, the fluctuating power is in the order of ferrocyanide is greater than phosphate, than sulfate, than chloride. The minimum concentration of an electrolyte in millimoles per liter required to cause precipitation of a salt in 2 hours is called coagulating value or coagulation value. The smaller the quantity needed, the higher will be the coagulation power of an ion. Then coagulation of lyophilic salts. There are two factors which are responsible for the stability of lyophilic salts. These factors are the charge and solvation of the colloidal particles. When these two factors are removed, a lyophilic salt can be coagulated. This is done by adding electrolyte or by adding suitable solvents. When solvents such as alcohol and acetone are added to hydrophilic salts, the dehydration of dispersed phase occurs. Under these conditions, a small quantity of electrolyte can bring about coagulation. Protection of colloids. For this purpose, you need some protecting agents. Lyophilic salts are more stable than lyophobic salts. This is due to the fact that lyophilic colloids are extensively solvated. That is, colloidal particles are covered by a sheath of the liquid in which they are dispersed. Lyophilic colloids have a unique property of protecting lyophobic colloids. When a lyophilic salt is added to the lyophobic salt, the lyophilic salt protects particles form a layer around lyophobic particles and thus protect the latter from electrolytes. Lyophilic colloids used for this purpose are called protective colloids. Emulsions we'll discuss in another